Now, this is what one of you has said, that when TTL becomes 0, packet is discarded. So here, what are we doing? We are basically, saying ping with, minus T1. Minus T option is the TTL option, and we are saying TTL option is basically, 1 is the TTL, right? TTL value is set to 1. Okay. Now the default value of TTL is set to 64 in Linux and 255 in Windows. You can check that, when next time you do ping, you will find that the reply usually comes back. If you are pinging a machine in the same LAN, then the TTL will be 64. Okay. If you are pinging a machine which is few hops away, then the TTL will basically show how many hops away it's been, right, in some sense. So if you can change the value of the TTL in the ping command. It's a very powerful and beautiful command, has many options. So you can explore by doing man ping. Ping minus T1 says TTL is equal to 1, and I'm saying 172.16.20.2. Now note that 20.2 is very much available on the network. There is a route, default route from host H1 to take you to router R1. R1 also can take you to, host H2. This is the example, in fact, we saw in the previous class for forwarding. What's the difference now? The difference now is I'm pinging it with TTL equal to 1. So what you need to understand is the router, when it receives this, first it decrements the TTL. Since it becomes 0, it is discarded. So when you say TTL equal to 1, it essentially means you can reach systems which are within your LAN only. Okay. You cannot reach systems which are outside your LAN. All right. So that is the important thing. Many people think that with TTL equal to 1, you can reach H2 from H1. No, that's not true. Okay. The first thing the router does is decrement the TTL, and if it's 0, it discards. It doesn't forward. It doesn't say, I look up the forwarding table, oh, I found the match, which is the next directly connected, therefore I can forward it. No, it doesn't do that. Okay. Let's look at this aspect. In fact, all these things, I made them actually as animations, but in PDF, you can't do animation. I wanted to just leave the questions, no answers, right? So all these clouds don't come directly if it is ODP that I am doing. Okay. Now, what am I doing here? I've generalized it. Instead of giving specific IP addresses, I'm generalizing to N0, N1, N2, and so on, because now we don't have to think specifically from a very well-known IP addresses. We know there is a network ID, host ID. So if I say N2.H3, N0.H1, it means that N0 is the network ID and H1 is the host ID. Similarly, N2 is the network ID and H3 is the host ID. But in our network here, we cannot see any host called N2.H3, right? So what happens? The packet comes from H1 to R1 because H1 has a default route to R1. I've shown the routing table entries for R1 and R2. Now here, what I want to emphasize is that when you talk about the next hop, okay, the next hop address, okay, cannot be N2.R2. Can someone tell me why? In the routing table of R1, I'm saying destination network N2 can be reached with the gateway as N1.R2. Yes, I did not say there N2.R2. I cannot say N2.R2. Can you explain why?
And because N2 is not connecting there.
Yeah, in fact, you are saying this is the route to N2. So it's something like saying somebody asks you, how do I get to, Madhapur? You say you go to Madhapur to reach Madhapur. I mean, it doesn't make sense because you don't know how to get to Madhapur. That's the point here.
Yes, ma'am.
You can say go to Gachibowli and take left because that person knows how to get to Gachibowli. Okay.
Yes.
So that is the sort of thing, right? You talk about what you know. You don't talk about what you don't know. And you're not directly connected to N2. In fact, you are saying, how do I get to N2, right?
Yes,
So the next hop address in the routing table is always the address on the common network. Okay, R1 and R2 share the common network N1. So their next hop address can only be the address assigned on that particular network. It cannot be some other, network's IP address. So I want you to note that, remember that clearly when you are looking at gateways. Okay. So now the packet has, a matching entry in R1. So R1 forwards the packet to R2. R2 sees that N2 is a directly connected network. So what does it do? It sends an ARP request for the host H3 because it doesn't have the MAC address of H3. Okay. And when it sends the ARP request, there is no ARP response, because of which it cannot send the packet to the host. It sends the ARP request multiple times, at the end of which it doesn't get a response. At that point of time, it sends a message which is called ICMP Destination Unreachable message. The reason I'm not able to reach the destination is because host is unreachable. Okay. I have put only host unreachable here because there is no space to write all that. But ICMP message consists of a type and a code. The type is destination unreachable. The code is, that is the sub reason, is host is unreachable. We'll see many different destination unreachables when we are going through the remaining slides. So here, the reason the destination is unreachable is host is unreachable. I'm sure you would have seen such errors in your web browser when you have tried to get to some sites.
Yes, ma'am.
Okay. Whenever you see an error in the website today, either from HTTP errors that you have studied or from the networking errors that I talk about now, you should be able to guess what went wrong.
Yes,
Okay. So that is the point. So this is basically destination unreachable because network is unreachable error. Okay, let's look at what is the problem here. We are pinging 172.16.21.2. Okay, now in H1, it basically matches the default route. Okay, this IP address 172.16.21.2 matches the default route. So therefore, the packet goes from H1 to R1. In R1, as you can see, there are only two entries, 172.16.12.0 and 172.16.20.0, neither of which match, the IP address with 21 network in the third byte. So the routing table doesn't have a matching entry. Therefore, the packet is discarded. In this case, the router R1 will send back a message to H1 saying, I don't know how to reach this network, right? So it says destination net unreachable because network is unreachable. Okay.
okay.
So this is the error. This is a second instance where we have destination unreachable message. Okay. You understand when you get network unreachable and when you get host unreachable now?
Yes, ma'am.
Okay. Now there are two more things. I can't display them with figures, so I'm just going to discuss that. You remember there is a protocol field in the IP header, right? So that can be UDP, ICMP, or TCP. It can also be SCTP, which is another transport layer protocol, or it can be, some other protocol which may not have been installed on your operating system. Okay, for example, by default, SCTP need not be installed on your OS. If you get a datagram, which is an SCTP datagram, then, the IP layer receives the data, everything is fine, the packet has reached the destination host, but there is no software to receive the data at the transport layer. In such a case, the ICMP message which will be sent back is destination is not reachable because protocol is not reachable. Okay.
Okay.
And when we see the transport layer, you have already seen the transport layer. There is something called a logical port which is associated with every application.
Yes, ma'am.
So if that particular port is not open, okay, so you get a packet saying to port 80, which is the port for the HTTP server. But supposing you don't have a HTTP server running on your system, then you get back the ICMP message, destination unreachable, port unreachable. Okay, so you have seen 4 destination unreachable now: network unreachable, host unreachable, protocol unreachable, and port unreachable. Okay, so these are the 4 conditions. Please be observant of what routing table entries I'm giving for each of the machines, because you have to understand that if there is no matching entry, then you'll end up with different errors. Okay.
Okay.
So host should have a default entry. If it doesn't have, that's a problem. Routing tables should have entries and routers for all the networks in the world, or at least, of course, a default entry. Any of these are missing, then you can't reach some networks in the world. So, you have to carefully examine the routing table entries.